Hey there, Calc kids. Today we're looking at 3.2 differentiability. Whether or not something you can take the derivative of it or not. Okay. Sometimes you don't have a derivative. Okay. Sometimes it fails. Sometimes when you go through and you plug it into your limit function, you get something that can't ever exist, like a 0 in your denominator, or a 0 in your denominator. Okay. And when you get that sort of thing, you just won't have a derivative there, and that's fine. Here's some examples. Noteworthy stuff, guys. Noteworthy. Anywhere where the one-sided derivatives are different. You can see here this slope's probably about -1 and this slope's 1. Okay, so at this point you can't draw a tangent because you can draw a bunch of different ways with only hitting it once. Okay, because you're coming in at 1 from one direction, -1 from the other, and crash, boom, no derivative. Okay, no derivative at a point. Okay, no derivative here, no derivative here. Okay, also a cusp. Okay, a cusp is basically a point. Okay, so there, no. Okay, you can't take the derivative at a cusp or a point. Sorry about that, we're gonna keep going. Also, a vertical tangent line, aka right here. Okay, at a vertical tangent line you have a slope of some number over 0, and you cannot divide by 0, right? So that is another spot where your derivative will not exist. So anything that looks like that, okay, could look like this, okay, that is where the derivative does not exist. And if you're discontinuous, it will not exist, which makes sense because you have a different derivative from one side as you do from the other, and we know that to have a derivative at any given point, the right side and left side should be equal, okay, to find the derivative. Okay, state that this function is not differentiable at the point x equals 0. Well, I'm going to save you guys a lot of time. What you have to do is take the derivative of both equations at this point 0. Remember, by doing that long, nasty equation, okay? And what you end up getting is, well, look at this. Here's a shortcut for you. If your equation's 4x, right? Well, your slope's always 4. So your slope of the tangent is always 4. So your slope of the tangent at 0 is 4. You got it. And now for your x to the third at 0, when you draw a tangent, it's 0. Okay, it's a horizontal tangent. And if one side's 0 and the other side's 4, there's no derivative there. Okay. I'm all tangled up. Okay. Most of the functions we are going to deal with will be differentiable where they're defined. They usually won't have corners, cusps, vertical tangents, or points of discontinuity. Okay. Most of them will be unbroken, smooth, with well-defined slopes at each point. Okay. Now, what it also means to be differentiable, if something's differentiable, it means if I zoom in and 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 zoom in, okay? So I get so close, it'll look like it's a straight line. Okay, and you can try this out with your calculator. Now, if you can't zoom in and it looks like a straight line, aka corner, cusp, discontinuous, or a well, those are actually over here, but a tangent one. Vertical tangent. Okay. So again, what this says is if I take a piece and I zoom in and zoom in again, it'll get closer and closer to looking like a straight line, which will be your tangent. Kinda cool. What it also means to be differentiable, if something's differentiable, then it has to be continuous, because discontinuous functions are not differentiable. So a function is differentiable if and only if it is continuous. Okay? So if f has a derivative of x equals a, then it is continuous at that point. Okay, the converse is false. Not every function can be a derivative. By the way, that was noteworthy, guys. That, not so much, but that was noteworthy. Not every function can be a derivative. If a and b, this is also noteworthy. If a and b are 2 points on an interval in which f is differentiable, and f prime takes on every value such that f prime, or between f prime of a and f prime of b. What that says is, if you can take, if a and b are in an interval where it's are differentiable, then f prime exists for every point in between f of a and f of b. Theory. And you can plug it in your calculator, which I'll show you in class. That's all there really is to this section so far, guys. So enjoy.